Hello students, this is a very basic and short presentation, only 7 slides, so that I can give you some initial clues or some initial examples to give you a clue about your STEM project. Maybe at the moment you are a little lost in regards to, you cannot find a proper STEM project. So this is basically, I'm gonna give you three examples of how your project could look like. That it doesn't have to be like this, but it's just, like I repeat, these are just clues, some examples, so that we can give you some sort of roadway you can follow. By now, your teacher should have explained to you that your project should address a problem in any of the three following UNESCO Sustainable Goals. Number 4, quality education. Number 6, clean water and sanitation. And number 9, industry, innovation, and infrastructure. So you can choose any problem within any of these goals. Our recommendation, though, is to choose the goal number 4, quality education. The reason for this is that this goal has a very wide and very almost limitless possibilities in regard to the type of project that you can do. Basically, if you choose this goal, you will be developing a prototype, some sort of game, some sort of didactic experiment or didactic device to teach a scientific principle to elementary kids, to kids in elementary school or in junior high school. And you have many possibilities within this particular goal. Nevertheless, you can choose something from this goal, clean water and sanitation, in order to make this possible for people around the world, and as well as the goal number 9. So let's begin. Examples about STEM projects. I will show you 3 examples of how your project could look like. I repeat, pay attention to this. Could look like. Does it necessarily have to follow the ideas behind any of these 3 projects? No, these are just examples, just to give you an idea. So let's begin with the project number 1, anatomic model of the eye and making of lenses to explain how eyeglasses work. And then I'm gonna go into project 2, how to make a toy hydraulic press or a hydraulic robot arm to explain how Pascal's principle work. And number 3, the creation of a parabolic solar stove for cooking or heating food with renewable energy. So let's begin. Project 1. Once again, what is this project about? It is the building of an anatomic model of the eye, of the human eye, and the making of lenses to explain how eyeglasses work. What goal is this problem within, or this project within? Under the number 4, which is quality education. What problem does it address? The problem that most of the adult population worldwide uses some kind of corrective eyeglasses, and even people that are not adults, right? Teenagers and some kids. But very few people understand how these things work, right? It's a tool, it's a gadget, so to speak, that almost everybody has some acquaintance with, but very few people understand how eyeglasses work, right? So that's a big problem in my opinion. And let me explain to you how this project can be laid out. So the first thing I'd like you to do is the following. I want you to look up this video on YouTube, defects of vision and their correction. How do spectacles work? Spectacles is just another word for eyeglasses from this YouTuber, right? And I'd like you to watch the full extent of the video. It's just 5-6 minutes, right? Okay, so go watch it. Okay then, so I'm gonna assume that you have watched this video. In this video, this person explains very well the problem with, let me go here. Okay, we have in here the anatomic model of the eye, right? And he explained to you 2 of the most common problems when in the eyes of the adults, right? Which is myopia, and the other one, which I forgot the name in English about. Okay, so basically, guys, you can make this anatomic model of the eye with some plastic or some, I don't know, some other type of material, whatever type of material you want. You can make this into a 3D physical model of the eye, the retina, the lens of the eye, right? And what you can do in order to explain how eyeglasses work is the following. You can create, you can create these things, guys, which are lenses. Okay, these are two types of lenses. Okay, and you can do them with epoxy resin, resina epoxica. This is the type of thing that you use in order to trap insects like this. This is epoxy resin. Okay, and it's not a very difficult process. It's not that dangerous, so you can probably help. You can ask the help of your parents in order to create these things on your own. These two types of lenses, and with these two things, and even more with more or less curvature, more of this type with more or less curvature, and the same for this one. With this set of lenses, now that you have them and you have created them, you can show how eyeglasses work, how these lenses work, I'm sorry, in order to correct, like this person did right at this minute, approximately. Okay, this is the lens of the eye, and this plays the function. This is the lens that plays the function of eyeglasses, and with this thing, the problem is corrected. You see? So that's basically what you can do. Make the anatomic model of the eye, right, in 3D. Put a lens that functions as the human lens in the eye, and then provide the corrective lenses in here, right here, lenses both of which you have done with this type of resin. Okay, so that's one project. This has been done previously in CDEP about 3 years ago. So that's the first project that I can tell you about, right? Okay, I'm gonna make a pause, and I'll be back with you for the project number 2. All right, so project number 2, how to make a toy hydraulic press or a hydraulic robot arm to explain how Pascal's principle work. So this project is within the goal number 4, once again, quality education. And the problem it addresses is the following. The problem to explain Pascal's principle to kids in junior high school in a highly interactive and engaging way. Bear in mind, guys, that if you decide for the goal number 4, which is quality education, basically the problem you will be addressing when you choose this goal is to explain some principle, some physical principle, or some mathematical principle, some chemistry principle, etc., in a way in a highly interactive and engaging way, mostly to junior high school kids and to kids in elementary, right? That's basically what the problem that is going to be about, to help explain something to kids. So now let me go into the explanation of the project. So I suppose by now you have seen this object, this tool that we use in order to lift cars, right? Okay, this is known as the hydraulic jack in English, and in Spanish this is known as el gato hidráulico. Okay, and we use this object every time we want to change the tires of the car or do some other maintenance below the car. Okay, so how is it possible, guys? This is the question. This is the detonating question. How is it possible that a person which is not very strong, I mean, we're not very strong, How is it possible that we can raise a car weighing perhaps 1,000 kilograms or a little bit more in such a simple way with some little pushes in here? As you can see, how is this possible? How does this tool allow this person to do such a feat, right? It's quite remarkable. Okay, so that's the question. That's the question. And then you investigate a little bit about how hydraulic jacks work, like under what principle, under what physical principle these tools work, and you will find out that they work under Pascal's law or Pascal's principle, like I said before. Okay, I'm not gonna go into the explanation of this thing. You can look it up later, and then you set yourself to try to explain this thing. Try to explain this thing once again to junior high schoolers or elementary kids. And basically, what you can do is this: you can recreate the same thing in a highly interactive or fun way. For example, you can create a hydraulic press. Okay, if you look for this video, how to make powerful hydraulic press from the Q, that's the YouTuber. Okay, they are creating something very similar to a hydraulic jack. It's not exactly the same, but it's very similar. And with this device that you'll be constructing, you can apply large forces to objects. Let me show you. You're going to be able to apply large forces. Okay, here we go. Okay, this person is going to be able to apply a very large force on this soda can by the application of a very small force with his hand. Here he goes. Okay, you can see it's a very small force that he is applying as an input, and you will see how much the output is. You see? The small force goes in, large force goes out. That is how we use a hydraulic press, and that is how this thing works, guys. A small force goes in, and a large force goes out of this tool. How is that possible? You're gonna look into this, and then you're gonna be constructing this type of device in order to illustrate, in order to show kids how this principle works in a way that is engaging for them, and in a way that they can actually put to use. You see? Very nice. And now I think they're gonna crack some nuts. Look at this. You see? Okay, so that was the second idea. Once again, let me make a little pause, and I'll be back with you in a moment. All right, so we continue with the last project number 3, the creation of a parabolic solar stove. What goal is this within? It's under the goal number 4, quality education, and I think also under the goal number 9, which is industry, innovation, and infrastructure. So let's take a look at this. What problem does it address? Well, this is gonna be addressing about we can see it like 3 problems. It's gonna help explain the properties of a parabola in mathematics. That's one problem it addresses. It's gonna help fuel interest in the usage of renewable energies. Suppose you want to get people interested in the usage of renewable energies. Okay, so then this project might be very good for such a thing. Or you can see it addressing this problem, the problem of providing people in marginalized areas with the means to cook their food or heat their water without any electricity, using only the sun, which is obviously a renewable energy. So let's see how this looks. Okay, so this is what we know, guys, as a parabolic mirror. Okay, let me show you first a little bit of the video.
The process.
get a feel of this, probably you have seen this type of thing before, right? In here, this person is actually providing some smoke in order for you to actually see the rays of the sun and how they're going to be concentrating upon this particular point with the help of the mirror right there. So how is this possible, guys? Well, you're going to be investigating about the properties of a parabola. This mirror is actually done in the let me show you right here, right here. There you go. This is a parabolic mirror. This shape is a section of the parabola, and it rotates in space. So that is what is known as a parabolic mirror. So you need to investigate. If you, let's say you decided for this project, you would have to investigate about the properties of the parabola, right? And how the parabola has the characteristic of when rays hit on the mirror. Let me use my drawing tablet for this. There you go. Okay, the parabola, guys, has the property. If you draw a section of the parabola right here, okay, when rays hit the parabola in a perpendicular way, like this, perpendicular to this axis, right? And if all the rays are parallel to each other, as you can see here, suppose these are the rays of the sun, okay, and then what the parabola is going to do for you is that it's going to concentrate, it's going to reflect each of these rays of light into a specific point, like so. It's going to redirect all of those rays of light into a very, very particular point, which we call the focus, like this, okay? And that's what makes this type of thing, guys, this type of tool very very usable when you want to heat whatever, food, water, etc. If you have no electricity, right here, you know, when you are out in the wild, in the forest, or any marginalized area where you have no access to electricity, you can heat food to a very big temperature, okay, by putting the food right at this place, or the water, right, and then putting the mirror below, and basically that's how it is, that's how it works, okay? You can actually attain very high temperatures with this thing if the sun, obviously, if the sun is out and the weather is the weather is on your side. Let's say if there are no clouds, if it's not cloudy and stuff like that, okay? So you can do this, guys, with very simple materials, all right? And basically you're gonna be addressing all these things that I told you before, okay? You're gonna help explain the properties of the parabola. How is it possible that that shape redirects every single ray into a specific point? You're gonna fuel interest in the usage of renewable energies. And if you, let's say, if you could somehow produce these things in a large scale and providing people in marginalized areas with these things, well, you're going to help them with the means to cook their food or heat their water without the usage of any electricity, as long as they have clear days, so to speak. Okay, guys, so I'm just giving you 3 examples. Then in a moment, I'm not gonna go into the reading of these things in the explanations because I think this video is long enough already. So just pause the video, and in here I'm offering you some suggestions, at least 4 of them, into how to make your STEM project in the best possible way. Okay, so read each of these, ask your teacher questions about it if you have any type of doubt, and we will be addressing all of your questions and doubts as soon as we can. So thank you so much, guys. See you later.